this is Aman, your subject matter expert for automobile engineering. Today we're going to discuss about the mechanical CAE in automotive design. Start with the basic introduction. Like the computer aided engineering is a concept that was first proposed by J. Lemon in 1980, the founder of SDRC, as a way to provide analytic information in a timely manner in the product development process, and through doing this, product and production process with great improvement are made possible. According to Lemon, he describes technologies to automate computer-aided drafting and computer-assisted NC tape preparation are available and beginning to be used widely to help reverse the alarming trends of declining productivity in many industrial economies. So when we talk about CAE, so we go to the conventional development process or the conventional development procedure and how CAE affects. So let's look on the conventional development procedure. The development of all mechanical products, not just an automobile but in many sectors, it proceeds a series of steps. Like the first step is the planning, then the designing, then prototype, then evaluation, and then final production. In this, the fourth step is the evaluation part, which plays a very crucial and critical part. If the prototype when evaluated, if it doesn't meet our standards or if it doesn't meet our requirement, then it again goes to design. Hence in this there is an iterative cycle between design and evaluation. Let's say if we make a plan and we make a design, then we make a prototype and we evaluate it. If that works fine, then we go to the final production. But in evaluation, if it doesn't meet to our requirement, based upon our evaluation, if it doesn't meet our standards, then again we go to the design part. That is, again we have to restructure it. So now let's talk CAE in terms of crash worthiness. As we see, there has been a number of media outlets which says that crashworthiness is the most critical item to each automobile company standard, which are made with reference to Japanese government assessment as well as the assessment of other countries. CAE as numerical experiment are used here and coming to calculate a large deformation non-linear analysis that has recently been used in conjunction with human body models. Crashworthiness is determined by, for example, let us take an elastoplastic analysis that is not just a simple matter of calculating the cabin. The cabin is rigid and the front end crushable zone is soft, so that the number of elements and the analytical model used in this calculation are detailed and complex. So let's take a look at the difference between the development procedure with reduced iterative cycle by CAE and the conventional development procedure. In case of conventional development procedure, we see that there are 5 processes or 5 steps, like the plan, design, prototype, evaluation and production. Whereas in this CAE we have 6. That is, we introduce CAE in the third step. That is, in case of a CAE design, production development procedure, we introduce CAE, that is plan, design, then CAE, then prototype, then evaluation and then the final production. Here in this we see a massive advantage, that is, we don't have to wait or we don't have to go till the fourth step, which costs us major amount of time, resources as well as workforce. In this, if let's say if a design works fine or if a design works good, we can finally check its output in a real life simulation by using CAE, that is computer aided engineering, and once it finds if it suits, then we go to the prototype, then we evaluate it. As the design and the CAE have been evaluated in the previous steps, hence evaluation plays a not that important role over this, and in this the reduction of iterative cycle by CAE, that is the iterative cycle which was continuing from the evaluation to the design part, have been reduced dramatically by the introduction of CAE in the procedure. Hence in CAE we have this model as we plan, then we design, then we have the CAE model which is also included in the design, for which helps us in reducing our time, cost and major resource. Then we go to the prototype, then we go to the evaluation, and finally the production part. Talking about strength and durability performance. In contrast to the crash worthiness, which requires an analysis that handles rigidity and elasticity well, the analysis of strength and durability performance requires the discontinuity of localized rigidity be cancelled out. Helping this along is the fact that CAE has an evaluation procedure to replace simple tests such as stress strain test has become increasingly common since its introduction. So that's all from the CAE in crash worthiness and strength and durability aspects. So we'll move on to the next part in the next audio. Thank you for your patience and time.